This is the start of section 8.2, graphs of the other trigonometric functions. We've spent a lot of time in class graphing the sine function, the cosine function, and transformations of those two. Now we're going to focus on the other four trigonometric functions: tangent, cotangent, secant, and cosecant. And the first one we're going to look at is tangent. We're going to graph this in detail, first of all, and then in the next video segment, I'll give you a shortcut way to generate the graph of tangent without having to work so hard. But for right now, we're going to just start from scratch and work in detail. So I want to graph tangent, y equals tan x. I've set up a table of values ahead of time with, notice, some of our familiar x values for angles: pi over 6, pi over 4, pi over 3, pi over 2, so on and so forth. And I also have a graph grid ready to plot points. The graph grid looks a lot like the grid we used when we graphed sine and cosine for the very first time, working from the unit circle to the xy plane. So let's go ahead and calculate some of these values. Now I'm going to use the fact that tangent of x is always equal to sine of x over cosine of x to figure out some of these values. So for instance, when x is 0, tangent of 0 is going to equal sine of 0 over cosine of 0. Sine of 0 we know is 0, cosine of 0 is 1, 0 over 1 is 0. At pi over 6, we get sine of pi over 6. Sine of pi over 6 is a half, over cosine of pi over 6 is square root of 3 over 2. And so when I divide those, sine by cosine, I get 1 over the square root of 3 is what that simplifies to. And to plot a point, I need a decimal here. That's on my calculator. I get that that's about 0.58. At pi over 4, we know the tangent of pi over 4 comes out really nice, right? Because sine of pi over 4 is square root of 2 over 2. Cosine of pi over 4 is also square root of 2 over 2. So when we divide those, we get 1. Tangent of pi over 4 is 1. At pi over 3, the sine of pi over 3 is square root of 3 over 2. The cosine of pi over 3 is a half. When I divide, I get square root of 3. On a calculator, I get about 1.73 for that. Now, at pi over 2, if I take sine of pi over 2 and divide by cosine of pi over 2, sine of pi over 2 is 1. Cosine of pi over 2 is 0. 1 over 0 is undefined. So what we're going to see with these remaining trig functions is that there are many values of x for which the functions are undefined, and we got to figure out what that means on the graph. Now, as I continue on to 2 pi over 3, I'm just going to pull out my unit circle to help me think about where we're at here at 2 pi over 3. Remember, sine values are positive, cosine values are negative, right? So the sine of 2 pi over 3 is square root of 3 over 2. But the cosine of 2 pi over 3 is negative a half. So when I divide, I'm going to get a negative number. I get negative square root of 3. So that's about negative 1.73. At 3 pi over 4, similar thing happens, right? I'm going to divide a positive by a negative. So it's square root of 2 over 2 is the sine, divided by the cosine is negative square root of 2 over 2. So I get negative 1. And so these values are very similar to some of the values I've already gotten. At 5 pi over 6, the sine is positive, cosine's negative. When I divide, I'm just going to write the result here. I'm going to get a negative 1 over square root of 3, negative the value we got at pi over 6. So that's negative 0.58. At pi, let's see, I get sine pi over cosine pi. Sine of pi is 0. Cosine of pi is negative 1 here for my value on the unit circle. 0 over negative 1 is 0. That's perfectly well defined. We get a 0 value. Now let's plot some of these points, okay, on my graph grid. Now I marked off pi over 2, pi, 3 pi over 2, 2 pi, and I left some unmarked tick marks here. I think we're used to this scale. Actually, each square going across is 15 degrees, or pi over 12, so 1530. This is where pi over 6 goes, then pi over 4, then pi over 3. And on the other side of pi over 2, again 90 degrees, plus 15 more. This is actually 2 pi over 3 here. And then 2 pi over 3, 3 pi over 4, and 5 pi over 6. So 3 pi over 4, 5 pi over 6, and pi. And let's plot some. We got 0, 0. We got pi over 6 about 0.58. Pi over 6. Notice how I marked my vertical scale. So 0.5 is about right here. Pi over 6, 0.58 is going to be above that. Pi over 4, 1 would be the point right there. Pi over 3, 1.73. This is like 1, 1.25, 1.5, 1.75. So pi over 3, 1.73 is really close to that crossing on the grid. And let's see, then pi over 2 I'm undefined, so I have no point to plot. For these points I've plotted so far, it looks like we can connect them up in that way. Looks good. Now as I move on to 2 pi over 3, my y values are now negative, right? So 2 pi over 3, I have negative 1.73 about down to there, very close to negative 1.75, right? I have 3 pi over 4, negative 1, so negative 1. 5 pi over 6, negative 0.58, so there's negative 0.5, negative 0.58, so a little further. And at pi, I have 0. Back to the x-axis. So I get another portion of the graph that I think looks kind of like this. We got to figure out what's going on between pi over 3 and 2 pi over 3. Already we can see where we've bursted out of that interval from negative 1 to 1. So there is something very different about tangent, very different from sine and cosine. So I'm going to put some more detail here. I'm going to call this more detail. And just this one time we're going to go into this level of detail here. And I'm going to put some more x and y values. Now, pi over 2 is like 90 degrees. I'm going to back up a little bit from 90 degrees and go a little bit beyond it. And it helps me, it's a little bit easier for me to give these as degree measures. 89 degrees, 85 degrees, 80 degrees, 75 degrees. So I'm going to plot these guys. Now, these all have radian measure, and you don't need the radian measure at your fingertips, but just be aware. 75 degrees is 5 pi over 12. 80 degrees would turn out to be 4 pi over 9 if we made that conversion. 85 degrees, okay, this is getting ugly, 17 pi over 36. And 89 degrees as radians, as a fraction, it's 89 pi over 180. Okay, that's... Ugh. Now, I use my calculator here, by the way, to get these. We don't have any way of figuring these out by hand. So for 75 degrees, I got 3.73. For the tangent value at 80 degrees, 5.67. And 11.43 at 85 degrees. At 89 degrees, I got 57.3. Remember, at 90 degrees, at pi over 2, we're undefined. And then I also just want to indicate what happens at 91 degrees, 95, 100, and 105. 91 degrees, when I check on my calculator, I get negative 57.3. 95 degrees, negative 11.43. At 100 degrees, negative 0.567. At 105, negative 3.73. So notice there's a positive-negative relationship between the values on one side of 90 degrees and the values on the other. And we won't be able to plot all these points, but we are going to make an observation on our graph from them. This over slightly, and actually go that way. And put these guys here. 75 degrees is actually right here on my graph just before we get to pi over 2. 3.73, I can just about fit that on here, right? It's up here. This graph just starts taking off, going up steeper and steeper. As I get really, really close to pi over 2, like 89 degrees, I would have to plot a point that's, way off my grid, way the heck up there at 57.3. On the other side of pi over 2, this tick mark is negative 3.73. So about down here, we're plunging down in a negative direction. And if we look just to the right of pi over 2, say at 91 degrees, I mean, we have a very negative number, negative 57.3. Again, that can't fit on my graph. So to one side, the graph is shooting up into space, up higher and higher. On the other side, the graph is plunging down. What's happening at pi over 2 is something we call a vertical asymptote. I'm going to draw a dotted line. There's no point to plot at pi over 2. This dotted line just is meant to represent the fact that the graph is shooting upward, getting close to that dotted line, never quite touching it up here. And on the other side, it's plunging downward, getting closer and closer, never quite touching it. So we call that a vertical asymptote. All right, now we still got more to go. I want to keep plotting beyond pi, and I'm not going to, it'll take forever with this level of detail. So what I'm going to do is I'm going to just, as I go beyond pi, I'm just going to plot 5 pi over 4, 3 pi over 2, 7 pi over 4. 5 pi over 4 is here. 3 pi over 2, 7 pi over 4 is between 3 pi over 2 and 2 pi. And 5 pi over 4, 3 pi over 2, 7 pi over 4, 2 pi. A few more values to help us see the pattern of what's going on. At 5 pi over 4, both the sine and cosine are negative, right? In fact, it's negative square root of 2 over 2 for the sine, negative square root of 2 over 2 for the cosine. So the tangent is back to being positive, right? We have a positive 1 value at 5 pi over 4. And If I filled in more values, we would see that the values in the third quadrant are all going to be positive for tangent. At 3 pi over 2, if I take sine of 3 pi over 2 over cosine of 3 pi over 2, sine of 3 pi over 2 is -1. Cosine is 0. Here's another value where the tangent is undefined. So what's going to happen on our graph is we're going to have another one of these vertical asymptote situations. So I'll draw a dotted line. At 7 pi over 4, sine is negative, cosine is positive, negative square root of 2 over 2 over positive square root of 2 over 2. And this will be true for angles throughout the fourth quadrant. I'm going to get a negative value again. Why don't I do 2 pi here? Sine of 2 pi over cosine of 2 pi. Sine of 2 pi is 0. Cosine of 2 pi is 1. I get a point on the graph at 0. So at 7 pi over 4, I'm -1. 2 pi, I'm 0. Now, I'm not going to plot more points. I think you can see the pattern. Going back to 5 pi over 4, as we move closer to 3 pi over 2, again, the values are going to increase larger and larger. As we back up from 2 pi and go to the left, we're going to dip down. As we get closer to 3 pi over 2, the values on this side are going to get more and more negative. As I increase to 5 pi over 2, the value of tangent at 5 pi over 2 is the same as at pi over 2. So it's once again undefined. Another vertical asymptote. And the graph is going to look like so. Now, we also have negative x values that we could plot. And really the pattern continues in a negative direction, just like it does for sine and cosine. At negative pi over 2, tangent is undefined. Because at negative pi over 2, the sine of negative pi over 2 is -1 cosine, and negative pi over 2 is 0. We're trying to divide by 0. And we're going to have a piece of the graph going downward like so. So here is a portion of the graph, a tangent. I can't draw it all because it extends infinitely in each direction. It's going to be copies of this sort of wavy pattern or that get repeated over and over again, separated by these vertical asymptotes. It's kind of interesting that one period of tangent from here to here is one period. Now from negative pi over 2 to pi over 2, that's actually a distance of pi units. So one period of this graph is pi, and we'll talk more about that as we go on. But for now, I'm going to stop. In our next segment, we'll have a shorter, quicker way to generate this graph, and we'll also talk about some of the important properties of tangent. Let's just add to this picture. This is our graph of y equals tan x.